Hello, welcome to our webcast today. Today we're going to discuss everything Couchbase Mobile, Edge, and IoT. More and more customers are heading to Couchbase for these always-on features, which we will be discussing today in detail, complete with conversation and excellent demos from our presenters. Some housekeeping items. Please use the chat function to say hello to fellow listeners throughout the session. Also, use the Q&A and ask any questions you might have during the presentation. Most likely, we'll save the questions for the end, but do feel free to ask at any time. There are some documents in our docs section, including a link to a GitHub, and also some more information on our solutions, so you'll want to check that out. Finally, we are streaming out to LinkedIn Live today, so hopefully we'll have some interaction and questions from those listeners as well. Today, we're joined by Wayne Carter, Vice President of Engineering at Couchbase, and also Mark Gamble, Product and Solutions Marketing Director, who will kick off today's session. And thanks so much for being here, you guys.
Awesome. Thanks, Suzanne. Hi, guys. Mark here with Couchbase. I'm super excited to be here today to talk about Couchbase Mobile, my favorite product in the entire world and the best mobile platform on the planet. Of course, it's a mobile data platform that includes a cloud database, an embedded database, and automatic data synchronization, as well as comprehensive support for AI throughout. And I'm really excited to have Wayne Carter on with me today to explore the topic, and he's going to show a live demo. Wayne, thanks for joining me today.
Absolutely. Excited to be here, Mark, and looking forward to the talk.
Me too. We have really a packed agenda. We'll start by discussing how edge computing solves data and AI processing challenges for mobile applications. And then we're going to move into an overview of Couchbase Mobile, where we're going to explore how it fits into the edge architecture seamlessly. And then we'll roll into that live demo. Wayne's going to be showing a live demo of Couchbase Mobile in action with synchronization and vector search. So it's going to be really exciting. And then we'll cover off on some use cases of an actual mobile data platform, including Couchbase customers. So real world use cases. So be sure to stick around for the whole program. And with that, we have a lot to cover in just a little bit of time. So let's get cooking. To set the stage, this slide really kind of encapsulates the end goal for many of our customers, right? They want to produce applications that adapt themselves for the individual users of those apps, because that's what keeps people using them. And by adaptive, we mean apps that are hyper-personal, that feel like interacting with a friend or trusted advisor. They're in context. They present relevant options that make sense to the user. They're driven by trustworthy data for accuracy, and they operate in real time and work everywhere, with or without the internet. And, Gen AI lately is really propelling expectations for this type of experience in apps even more. And it seems everyone is really clamoring to build it. And arguably one of the most critical pieces of the puzzle to achieve these types of application experiences is data, right? Where you process it and how you process it can have a huge impact, both positive or negative, on the user's experience with any given application. So it should be no surprise to any mobile app developers that are in attendance today. Users don't just expect, apps to be innovative and personalized and responsive. Of course, all of these things, but they actually expect magic, right? They want apps to defy physics and work at lightning speed all the time, no matter where they go. They expect an always fast, always on experience, or they'll abandon an app without hesitation because there's so many options out there for them. And to make matters worse, users are pesky, right? They're constantly moving around in and out of network coverage, and that makes meeting these kinds of expectations even more difficult. So how can an app deliver always fast, always on experiences under these types of conditions? So the challenges in meeting these expectations can be arguably and largely rolled up into these 4 core points. First and foremost, speed. Apps need to provide an experience that meets the demand of their users who expect them to respond immediately with the information that they need. And reliability. The apps need to be always available and impervious to internet slowness and outages that's inherent with any kind of internet model. Apps that handle sensitive information have to be secure. They have to adhere to strict requirements for regulatory compliance, and so thus be governed. And also bandwidth usage, right? Network usage can really be a choke point for applications. Shared capacity introduces unpredictable bottlenecks, and egress charges for data from the cloud tends to get pretty expensive, right? And these represent top challenges that our customers face, sort of in a nutshell. But they also represent key benefits that they get from Couchbase Mobile. So mobile app user expectations represent, really a growing class of apps that require 100% uptime and real-time speed guaranteed, regardless of internet connectivity. And edge computing is the answer. This is the means to achieve this. The goal of edge computing is to bring data and compute closer to applications that consume it. And to do so, you need to do things like embed a database to edge clients, reducing dependencies on the internet. And you need to synchronize data from the edge to the cloud and between devices for consistency and integrity. And this model speeds up apps because data doesn't have to travel all the way to the cloud and back. And it makes them more reliable because local data processing removes that latency and slowness from the internet, as well as outages from the equation. And it handles privacy better because sensitive data never has to leave the edge. It can stay where it's private. And edge computing promises more efficient bandwidth usage by lessening the load between the cloud and the edge. And this is, again, important when on shared networks where bandwidth can vary greatly depending on time and demand. So, why is it that a cloud-only computing model introduces problems for apps at the edge? Well, let's start out by taking a look at a simple example. So we've all been to the supermarket, right? And a growing trend we're starting to see in every market is this self-checkout kiosk. We see them at stores like Whole Foods or Home Depot. And these kiosks, seem to provide a convenient way to expedite the checkout experience. Let the customer do the work and save staffing fewer high-priced cashiers. The customer wins, the business wins. But is it really faster? Is it really more convenient? Studies are really showing that the experience is in fact slower than if a customer uses a seasoned cashier, a human, who could simply look at an item and key in the price because they've been there and they gain that kind of knowledge. But as a customer, you don't have that background knowledge of items, and you don't know how the kiosk functions inherently. So you can't actually, you actually will spend more time fumbling through buttons and searching for items manually, especially those with no barcodes like vegetables or hot bar items. And the process can take, let's say 25-ish seconds or more per item, which can add up if you've got a cart full of items. And what's more, if the cloud is where the data is for the application is stored and processed, latency can actually slow down the experience. And that can cause errors as you click buttons multiple times. You might advance forward late, and then pretty soon you're going back and forth and getting yourself into a conundrum. And overall, this can cause errors as you at the end, causing frustration. And in many cases, customers will in fact choose not to use the kiosks unless they only have just a small handful of items, simply because of these issues. There are dozens of studies out there showing this. And for the business, the issues mean lost potential revenue. Slower transactions means fewer transactions, as well as lost customer confidence. So with that, Wayne, I'd like to ask you to dive into some of the reasons that a cloud computing model can cause these issues. Can you help explain that for our audience?
Yeah, let's start by looking at like what you described there. That's like any gate in a business process that you're trying to solve with digital technologies are going to fall into the strengths and weaknesses that Mark just went over, right? So if you're doing a checkout at a retail location, or if you're boarding a plane, or delivering packages where you're trying to do that kind of business transaction, if the digital technology that you're dependent on is not the architecture you use for the application that you're depending on matters. So traditional architectures use cloud computing, right? So you have a web service, some kind of services or applications in the cloud that's backed by a database. And then your applications, whether that's on a phone or a web browser, or a laptop or a kiosk or any other client system, is going to access those services over the internet and provide the functionality of the application. And when the internet is working well, the applications work well, right? They're pretty responsive, right? You're going to have latencies in like a couple hundred milliseconds. That's pretty typical of a good functioning application with a good network connection. But when the network starts to be a little less reliable and get slow, then the application's performance is going to slow down, right? We've all had that problem where we get the spinner, right? We try to use some functionality that depends on the internet. We get a spinner. It says just like, hold on a second, we're trying to help you out. Give me a second. And then when the internet's not available, those types of the applications that depend on this type of architecture, they just don't work, right? We've also seen this where it says, internet not available, try back later. And this is just the inherent limitations and capabilities of cloud computing, right? You're dependent on some compute resources that are, far away from you, and you're going to use a network to do that. And so if the network's not available, then you won't be able to get to the resources you need. All right, so let's contrast that with edge computing. So starting with the same cloud computing architecture, we have web services in the cloud, right? We have a database backing those. And then I've added a few an additional layer here, right? We have an edge layer where I'm imagining that in San Francisco. And then, of course, the client layer that we started with before. Now let's convert this into an edge architecture. So the first thing I'm going to do is I'm going to clone down my environment from the cloud down to the edge. And you might size that a little differently. Right? Your edge environment will likely be sized a little bit smaller than your cloud because you're offloading load when you do that. Now let's take the next step. So now we're going to connect our device to our edge region and then connect our databases between the cloud and the edge, right? And now I have an application that is dependent on a service that is nearby. And now if I want to make that even more complete, right? Let's say that I have a data center in the West, right? But I also want one in the East, or maybe I want one in a different country. I can start cloning these and make the edge topology a little bit more complex and give myself these places where I can actually have resilience to network speed problems or connectivity problems or capacity problems. And so now let's clone my West to my East, and then we'll connect them using synchronization between the top level databases. And let's make it a little bit more complex. Let's bring in another location that doesn't have an edge region nearby. So I'm gonna use LA. It's not far away, right? It's in San Francisco, and I've also got my West region, which isn't that far away, but I don't have something local to LA. So I'll connect that to my closest location, which in this case, I'm just going to take the West location. I've determined that San Francisco is not closer, so I'm going to use the West. And let's make it a little bit more complex. Let's bring in more devices, right, and see how these edge topologies can help us, right? So I'll add a few more devices in each location. Add databases to those devices, because I can also move my edge topology onto the device itself, right? So then that I get advantages of local data processing and local compute. And then I connect my databases to my local databases in the edge and start synchronization. And I can also do peer-to-peer synchronization between local devices, like I've done here in LA. And now when the internet works, everything works great. The edge topology performs very similarly to the cloud topology, but you'll get a little bit faster speeds when you're connecting between devices that are closer, right? So you can see San Francisco is connecting to the San Francisco data center, so it'll be a bit faster than connecting to the West. And now when the cloud goes down, all of the systems that they don't have full dependencies on the cloud, so they can continue to operate. And then when the edge goes down, the devices that have the data local can continue to operate. And even when the local network that I'm using for peer-to-peer between those two LA devices goes down, the devices still operate. So even under total failure, network failure, the devices that have fully decentralized their data and using synchronization to keep it up to date can operate at full speed and full capacity with or without the internet. And so you can see how running on the edge between cloud DCs can be consistent, fast, reliable, and private and efficient. And also devices at the edge even increase that even more, all the way to 100% availability when you put the data on the device, and sub-millisecond response times, because the data is right there and it's guaranteed sub-millisecond response times. So for cases like that point of sale kiosk that Mark went over, you're going to be looking up prices and finding items at sub-millisecond speeds. So you remove all, and at 100% availability. So you're guaranteed that if someone is there trying to buy something, or trying to enter a plane, or trying to deliver a package, or doing any other business critical process, that you know it's going to work.
Yeah, thanks, Wayne. That's really really illustrates the solution to the problem elegantly. And as we circle back kind of to the point of sale problem that we opened up the use case with, edge computing solves those challenges. And as we fast forward from that kind of current kiosk model we talked about earlier to a more modern checkout experience enabled by local data processing and AI, imagine a smart shopping cart where each cart has a fixed tablet that can use cameras to visually scan each item as you put it into your cart, emulating that human cashier's speed and accuracy. And with edge computing in a mobile database, the data is processed on device and it removes internet latency from the equation, as Wayne said, sub-millisecond response times. And a smart cart can even facilitate payment, completely removing the friction of a checkout line altogether. And in this model, shopping takes just a few seconds per item instead of half a minute per item. And that means the customers are happier. That means the business can realize more transactions towards more revenue. And more satisfied customers. So really illustrative example, Wayne. Thanks for that. Now let's move into taking a look at Couchbase Mobile, the actual product stack. So first, I like to talk about Couchbase, the broad brush stroke of Couchbase as a whole. And Couchbase is a cloud-native NoSQL database that's used to power gigantic applications like those at LinkedIn. If you're watching us on LinkedIn now, you're a LinkedIn user, you're using Couchbase every day. But also Tesco and Comcast and Amadeus and United Airlines and big enterprise customers, household names who use it to power their critical applications. And Couchbase is multi-purpose. This means it's a combination of database capabilities. That's why we're able to facilitate and power such a wide array of different use cases. So first, it's the processing of key value information in memory for hyperfast responsiveness. And second, Couchbase leverages a distributed storage model of JSON document-based data for scale, resilience, and JSON also provides development flexibility. And to this, add support for vector search, full text search, eventing, columnar analytics, containerization support, mobile sync. These are all data access patterns that customers no longer have to stitch and bolt together from a bunch of different technologies. They get it all from one platform. And Couchbase supports relational constructs like SQL and ACID transactions, not typically found with a NoSQL document database, right? And this is so developers can use their existing SQL skills and adopt Couchbase more quickly. And looking at the deployment layer here at the bottom, customers can use Capella, our hosted and managed database as a service, or they can choose to manage their own Couchbase deployments in the cloud or on-prem. And this sort of represents Couchbase in a nutshell, if you will. And Couchbase's origins are in the merging of a JSON document database, CouchDB, way back in the day, with an in-memory key value store memcached. But we didn't stop there, right? As such, we're the original multi-purpose NoSQL database at that point, upon which we've built all these other data access patterns and capabilities. And zeroing in on some of the AI-specific features, we recently launched our LLM-based coding assistant called Capella IQ. And it helps developers write queries, write SDK code, and even debug SDK code. We've announced support for vector search in Capella, our database as a service, as well as Couchbase Server, the self-managed option, and Couchbase Lite, our embedded mobile database. And this enables the mainstays of vector search, semantic search, RAG, retrieval augmented generation, and when combined with full text search and SQL, also built into Couchbase, it allows for predicates and joins and aggregations, ranges and the like in a search. So complex searches can be answered with precision. And we'll talk about that as we go through. And we're also just about to launch our columnar analytics service. And this is a columnar data store that provides real-time analysis from multiple operational sources, more than just Couchbase. Think S3 or RDS or even MongoDB are all you'll be able to source them through for combined analytics. And of course, we have cloud to edge data processing capabilities thanks to our mobile database platform. And as we take a look at that, the Couchbase mobile product stack, this is how we support edge topologies, is made up of 3 foundation components. Couchbase Server, that's the flagship distributed NoSQL document database server, right, that we just talked about. And then Couchbase Lite on the other side, that's the embedded version of Couchbase for mobile and custom embedded devices. And Sync Gateway sits in between. That's responsible for secure data synchronization, routing, and access control between mobile clients and server tiers. And the capabilities can be deployed 2 ways: fully managed with Couchbase Capella, where Couchbase Server is known as Capella and Sync Gateway is known as App Services in the managed model. Or you can choose to deploy self-managed, and this is where you would install Couchbase yourself on public or private clouds, or on a cloud edge service, or on-prem. And another unique advantage here is that you can even combine the hosted model and the self-managed model for very bespoke hybrid topologies. So a little bit on Couchbase Lite. Couchbase Lite is the database that mobile developers and IoT developers would be working with. It gets embedded directly into the code base. It's a database that's running in the app, right? And it's full-featured, developer-friendly. It's got native support for iOS, Android, and Windows platforms. Customers build desktop and web server apps with .NET and Java. And the C API allows developers to build applications in C that run on nearly any embedded platform. Think Raspberry Pi or Arduino. Couchbase Lite allows our customers' development teams to develop faster because of that JSON flexibility, the simple-to-use APIs for database operations, SQL support, right? Not found typically in a NoSQL database, and comprehensive platform and language support that allows us to make this claim: any platform, any language, any device. As we then take a look at kind of the topology once more, reminiscent of what Wayne was talking about, albeit a little simplified, we fit seamlessly into this edge architecture. And that's because we run in the cloud, we run at the edge, we run on device. And most importantly, we automate data synchronization between the layers for consistency. If any upstream layer of this architecture goes out, downstream layers, as Wayne pointed out, are unaffected and continue to run. Even the devices, because of local data processing. And when the network's available again, the data synchronization automatically starts back up. So you don't even have to do it proactively. It's all automatic and maintains consistency across the ecosystem. So now let's take a quick look at how Couchbase Mobile supports AI from cloud to edge. And we're going to start with kind of the server tier, if you will, of that the mobile stack. So our Capella database as a service offers the Capella columnar service that I just talked about. a moment ago. And this is essentially a columnar data store for running complex analytics queries against operational data without any impact to the operational workloads, and without the need to even move the data via ETL into a separate repository for analysis. So it's great for real-time operational analytics, and it can be used as part of a data pipeline, of course, for machine learning training iterations. But it also brings the ability to leverage fully trained ML models via a user-defined functions feature. And essentially, this is the ability to call trained Python models right from the database using SQL. That is to feed a given set of data up to the model, perhaps to classify a customer, let the model run, and then incorporate those results back into the query response and pass it to the application. And on the server tiers, we also support vector search. I talked about this. This is going to be a game changer for our customers' applications. And this new feature is going to allow similarity and semantic search for better response precision for our recommendation apps and things of that nature. It also enables RAG, retrieval augmented generation, which make LLM responses more contextual and accurate. And what we feel, again, is most important, vector search can be combined with full text search and called using standard SQL. And this allows for more precise and contextual responses. So now let's take a look at the embedded database side of the equation here, because we support AI from cloud to edge, and that means, of course, at the edge in the database. So on the embedded database side, Couchbase Lite has this feature called the Predictive Query API. And this can be used to call trained mobile ML models at the edge, similar to its counterpart, Capella, in the cloud. But the thing is that this happens locally on device, on Couchbase Lite. So that makes the experience fast, sub-millisecond response time, and always available even when offline. And Couchbase Lite also supports vector search. This is an industry first. No other database platform offers vector search on device, which brings all the vector search benefits that I just mentioned to the edge, making the searches super fast, even without the internet. And the ability to power vector search on device is a unique differentiator for us. This other database vendors only offer vector search in the cloud. So thus, it's dependent on the internet and can suffer from some of those problems we talked about earlier. So vector search, the concept, is a means of leveraging AI to capture the meaning and context of unstructured data, including text and audio and images, and transform it into a numeric representation called vectors. And the models can compare vectors for a given input against vectors that it already understands that represent other data to find nearest matching items based on their semantic meaning. So a simple way to look at it is vector search looks for matches based on the meaning of the input, not just the input itself. So for example, here we see a simple search query for running shoes. Vector search finds the nearest related items, such as track shoes and cross trainers, providing a more complete and useful answer to the input. And I've been talking about this notion of hybrid search. Vector search is great at providing search matches in context, but it can't answer all questions by itself. So consider this seemingly basic search prompt. Find me casual, fun shoes that match the color of my car between $100 and $200 with good reviews in stock right now near me. This single question actually requires multiple search techniques to answer accurately. Matching a color from an image is a great use for vector search, but casual and fun might be best answered using text-based search. And the prices, ratings, and inventory criteria are classic where conditions and SQL queries, while the near me would be answered with a geospatial search. So the bottom line is vector search is powerful, but even more so when you can combine it with other search techniques and call it using a single standard SQL query. So when we consider now, I keep coming back to this depiction, but I think it's illustrative of what we're able to provide. So we consider now those AI capabilities available in Couchbase Mobile and apply them to the edge computing architecture. We see that Couchbase processes data and AI in the cloud, at the edge, and on device. And that brings the scale to handle the massive amounts of data required for accurate AI along with the edge capabilities for the immediacy to really make it effective, even when completely offline. So now I want to move in just for a moment to the IoT spectrum of edge computing. And we recently brought to market a plug-and-go SIM-based cellular network for expanding our edge support with connectivity to our database as a service, and essentially and specifically for IoT applications. So to power this solution, Couchbase partnered with Soracom, and they're a leading provider of dedicated cellular IoT connectivity for any device. And the Soracom SIM-based network brings the advantages of scale and simplicity by bridging multiple carriers to deliver a direct, secure conduit to the cloud. And it makes it really easy to deploy and easy to manage IoT apps of any size. And it removes essentially it removes connectivity barriers for the IoT developer. And it makes it really easy by being plug and go. So the concept is really simple. You get that SIM card, you insert it to your IoT device, and it's pre-configured to connect directly to Capella, our database as a service, using the Soracom network over MQTT. And this makes it easy for customers to quickly deploy fleets of IoT devices that can start collecting data immediately. And for devices with Couchbase Lite embedded, they can run indefinitely in isolation and sync over the network using Capella app services as that connectivity permits. So one last time to my favorite depiction of the edge architecture. But as we consider all these various capabilities applied to this architecture, we can run across the entirety of it. We have something truly unique here, the ability to power AI everywhere with data processing, vector search, AI models, and network connectivity from cloud to edge to device. So now I'd like to get to the fun stuff. Okay, Mark, enough of you. We want to get to the live demonstration. So Wayne, I'd like to turn it over to you, and let's actually see some Couchbase Mobile synchronization and vector search in action.
All right, great points. Let me stop sharing the slide, and then I'm going to share my screen. Okay. All right, and do you see my screen, Mark?
I do. We're good.
All right, perfect. So here's my little demo setup. Let me explain what I have here. So this is our reference application. It's called Simple Sync. You can search for it in the App Store as Simple Data Sync and download it on your phone today if you would like. And I have the device on the left here. This is mirroring my phone, right? So, and this is a simulator that I've got running on my device. And this application demos a few things, and I want to start with the color synchronization. This is the simplest type of demo, right? So what this is doing is if I click it, you can see that my device and my simulator are in sync. And so I click it on my device side, and then I'll click it on the simulator side, and you can see they stay in sync. And they're doing that using peer-to-peer replication. So my device that's in my hand, this one here, right, is peer-to-peer connection with the simulator. And what it's doing is every time I click the document or click the circle here, it's writing an update to the database saying, hey, the color for this app has changed, and I'm changing it from green to pink, and then that gets synchronized to all the devices, and they show the same result. Now this is also connected via Capella, and so let me just show you a setting really quick. So I'm going to click on my device and click here on settings, and you can see that I actually have for the device in my hand, I actually have a configuration for an endpoint in Capella, and it's enabled. And then if I go on my simulator, you'll see that it doesn't have a connection to Capella. And that's because it's using peer-to-peer to connect. And so, Mark, do you want to show us a little bit of what you can do from your side? Where are you right now? I'm in Miami.
Yeah,
Where are you?
we're coast to coast, Wayne. I'm in Carmel, California, and you're in
Nice.
Miami. So it doesn't get much more coast to coast than that. I have the application running, and we're going to synchronize via app services coast to coast. So I'm going to click it and notice that it went to purple on my end, and it went through app services and synchronized with Wayne's device that he's holding using app services. But bear in mind that the simulator is not connected to app services. It's not even on the internet. So what this is doing is it's demonstrating a complex topology at work here, simplified, if you will. But I'm synchronizing to the cloud and back down to Wayne's phone. But Wayne is synchronizing with other phones in local proximity via peer-to-peer. So this way you can create topologies where you'll have local concentrations of collaborators that can collaborate locally, but even collaborate via app services with other groups of collaborators on the other side of the planet, where only one actual internet connection is needed in each room. So really amazing capabilities here for synchronization, and really other solutions are just unable to achieve this level of sophistication with Sync.
All right. And then, Mark, can you make a change in Capella using, say, Nickel, like do a SQL query that updates the color, or maybe do a key value operation and kind of show
Yeah.
how you can actually make you can do database updates in the cloud, and that will also cascade out to all of the devices.
Absolutely. In fact, I'm going to go in and change a document directly that represents the currently displayed color. And I'm going to change it to Couchbase red, and I'll save that. So as I save it, it's now going to synchronize down from the cloud over to your devices, and it's done so for my device as well. This is now top-down synchronization, and I could have done this obviously using SQL, and could have, of course, this would have been otherwise also my application doing this. So a variety of different ways to change and synchronize this data.
So if you're like wanting to send a lot of data out to a number of devices, you could run a SQL query that updates, a partial set of the documents in the database, either sending it out to users, or you can imagine turning off light bulbs or turning them on in a more IoT case. All right.
Exactly.
So awesome. Great. Okay, so back to the demo. Let me kind of show you a little bit more of what we have in store. So synchronizing data like numbers and strings and dictionaries and arrays it's pretty easy and straightforward, but there's other things that you might want to sync, like binary data. And so whether that's photos, PDFs, videos, and that's what's shown here in the photo section. So as I click this, I have, again, a document in the database that I'm updating the image associated with that. So this is a PNG that's being replicated across devices. That will be to the cloud, across devices, peer-to-peer, etc. And then I might want to synchronize more complex values, right? So that's what's represented here in this count section. So this counter, right? Distributed counters are a notoriously hard problem, right? So convergent distributed counters, right? Counting is hard. And to solve that, you need to define a data shape that allows for the counter to converge. So you can see that if I push the plus button on my device, it goes to 27, and I push the minus button on the simulator, and it goes to 26. And now I'm going to show how the distributed counter will converge on a single answer when you have simultaneous operations. So what I'm going to do is I'm going to push plus on both my device and the simulator at the same time, and we should see an increment of 2 instead of 1. There you go, to 28. All right. Now let's move to the next one, which is search. And this really covers a lot of things that Mark talked about in his presentation. So let's start with full text search. All right, so if I click here, or in this search area, and I type in green, this is using full text search to find the green items in my database. And now I want to combine it. I want to make it a little bit more complicated. All right, so now I'm going to add some predicates using SQL. So I'm going to click produce here. And now what I see is, like, if I click all, right, I'll see, some of these things, and maybe green's not the right color here, but anyway, green and produce. So that'll actually say, just show me the green things that are in the produce area. And now let's make it even a little more complicated. So let's use vector search. Let's take a picture of something. So I'm going to click on this little photo here in the search bar, the camera icon, and I could take a photo. I could choose from my library, but I'm going to choose from one of these examples that's included in the device. And this is simulating kind of a local image capture. And let's just look for this bell pepper. This is what I'm looking for here. So now what I have is I've done a hybrid search that uses full text search, SQL, and vector search into a single query that and returns this single result. So let's look at the code associated with that, so you can see how it's done. So if you click on the I button here at the top left, you can see explore the code. This will take you directly to the search area since I was in the search demo, and let's look at how that works. So the SQL is, and let's actually switch over to my desktop so we can look at it in desktop form. And here's the GitHub repo if you want it. It's github.com, Wayne Carter, and simple-sync. Okay, and that'll give you access to the app and all the source code for this demonstration. So here's the SQL statement. Pretty standard. Has some additional functions in here for vector match and vector distance, and this match is for text matching, so full text search. We also have ordering capabilities using vector distance and rank from full text search. And then we have the category, like when we put in produce, right? So very, very simple query doing a very powerful operation. And so this is, once I have the SQL statement, this is how I set up my query and how I execute it. So just pull in the query, and you can see I have like the embedding, the category, and the search parameters. So I'm setting those here from my variables in the application, and then just executing the query and processing the results. And now if I want that to be fast, I'll want indexing, right? So you almost always want indexing. So this is how you set it up. This is just a normal index where I'm just indexing a name. The same thing for the category. And then I'm getting more complex indexing. So here's our vector index. Pretty straightforward. Just using an embedding with 768 dimensions. And I create the index. And then full text search is very similar. I want to be able to search across name, color, and category. All right, that's the end of the demo. Let me stop sharing. Back to you, Mark. Mark, you may be on mute.
Are you guys able to hear me now?
We are. There you are.
Excellent. Live television, folks. Love it. I was just regaling about the coolness of the demo and the fact that anybody can actually show what Wayne showed, because this application is out on the App Store. So use the QR code, go and get the app. You put it on 2 devices, and you'll be synchronizing between them in seconds. It's like magic. Really cool. And for the developers out there, all of the source code is posted for you to take a look at. That's what Wayne was just walking through. So as we wrap up, I want to leave a little bit of time for a Q&A. We're about a quarter to the hour. I'll try and wrap up in the next 5-7-ish minutes. But hopefully a lot of the applicable use cases are sort of popping into your heads organically. This, of course, is these capabilities we've been talking about are great for retail. Wayne just showed the concept of image-based search being used to find and match similar products, and that in fact also represents kind of the goal of the point of sale application that we looked at earlier. But it also, we can use vector search and AI and local data processing in games, right, to allow for offline first processing You can use RAG techniques with vector search to do things like enable LLMs to have non-player characters behave more naturally, more human-like, with real-time awareness of your, what lands you've been to, what awards you've been awarded, things of that nature in a game. And then cruise lines, on vessel data, AI processing can make sure that guests are always engaged. Passengers and crew can use their applications without any dependencies on the internet. And of course, vector search and on-device can power chatbots and fraud detection, predictive maintenance. So all of these type of edge applications that currently have challenges of the cloud-only compute model can really be solved with a database that's built for cloud-to-edge processing. And we'll take a look at, let's see, my sharing is a little bit frozen here. There we go. So I want to talk for a second about Quantic. They're a point of sale application, and they are essentially a full-featured cloud-based point of sale, and they offer the ability for their applications and their devices to run offline as a benefit, a value add for their customers. They needed a database with real-time sync that could keep up with their growing customer base, and they needed to eliminate downtime. They could not afford to be the business bottleneck for some sort of outage for merchants and retailers. And finally, they wanted to reduce their database management tasks so their development team could focus on product quality. So by adopting Couchbase Mobile, they now deliver an always-on, always fast experience through embedded data processing and real-time sync. And the fully managed database as a service, Capella, dramatically reduced their database management tasks for their developers. And that saved time and reduced costs. So by adopting Couchbase Mobile, Quantic gained this powerful way to guarantee speed and uptime while keeping pace with its expanding number of customers, products, and features. So a really cool use case, and there's a deep dive customer use case on our website. And then Lodem, they've been using Couchbase for a while, but they most recently adopted Capella as well as app services. Great example of cloud-to-edge data processing. They wanted to satisfy the demands of their fickle gamers who were getting upset that when they would go into an elevator or go onto a subway and lose internet connection, they couldn't play these games. So they turned to Couchbase to embed that data processing into the games to provide that always-on experience and super fast responsiveness. And the fact that they were able to leverage SQL meant their small development team was able to adopt Couchbase quickly. They were productive almost immediately. They have a game called 4 Picks, 1 Word. It's on all the major app stores and game stores, and it's addictive. It's really cool. And the synchronization also means that if a player in the middle of a game drops their phone when they get home from playing on the subway and pick up their tablet, they're picking up directly where they left off. And that was another critical component for Lodem. So this use case is also on our website. Be sure to check it out and download their game. It's a lot of fun, and you'll have another local demo of Couchbase running on your device. So as we wrap up and get into Q&A, hopefully I've left us enough time. Yeah, we've got about 10 minutes for Q&A. Just want to reiterate, our aim is to help our customers meet those goals of creating the hyper-personal AI-driven adaptive app that are in context, driven by trustworthy data, operate in real time, and work anywhere with or without internet. So in summary and conclusion, as we move into Q&A, Couchbase Mobile is the means to power that always fast, always on experience wherever users happen to go. And it fulfills that promise of edge computing: superior speed, superior reliability, superior privacy, and the most efficient bandwidth usage for mobile and IoT applications. And with that, I'd like to open it up for a bit of Q&A. And I think, Suzanne, you might help facilitate and Wayne, you be ready to answer the tough ones.
Happy to do that. Just a shout out, we did have a webinar late last year with one of the co-founders of Quantic, and he walks through the solution. I mean, they're talking about millions upon millions of operations. They're doing kind of a, food ordering database, system where they're accepting and working with various restaurants and various consumers. So really, really cool use of mobile. So please do check that out. It was just an awesome webcast, and I was so grateful to have their co-founder there. So on to Q&A. We have a couple questions here. One is from Paul. On server desktop for running your own models locally, can we use, I think it's llama.cpp or OLLama they're suggested similar multi-platform ways to run models locally on mobile across iOS, Android, etc.
Yeah, I see the question here, so I'll go ahead and answer this one. So yeah, you can use those models. The way it works on with Couchbase Lite, since you're talking about, well, I don't know if you're talking about Couchbase Lite or not, but with Server, you would enrich your documents with the embedding. So you would do that as an asynchronous process, enriching the documents with the vectors. And so you can just use any LLM or other types of AI or other types of models to generate the embeddings, including the ones that you've listed. And then for Couchbase Lite, if you're running on a laptop or on a device and you're using the embedded database, then you can, we have predictive query, or you can call out to your own model and use enrichment. The difference between those two is predictive query will actually store your embeddings in the index, but not in the document, which has some benefits. Right, so you're not syncing the embeddings around, which can be beneficial. You may want to, you may not want to. But one of the benefits of putting it in the index is it won't sync. Or you can enrich your documents like I described. For Server, you can do the same thing for Lite.
So just to follow on, he says he's talking about for generating vector embeddings for queries locally on mobile.
Yeah, so you would just use an LLM that will run on those devices, and there are quite a number of them, and the number is increasing, every day. So just grab an LLM and use our either predictive query API, or you can, when vector search comes out, we also have an async indexer. That's the one I'll probably use a lot. That way I can create lazy indexes. So it's pretty straightforward, Paul. You just grab the LLM and then use it alongside Couchbase Lite. I did see another one here from Daniel. Can VB vector standalone be used standalone, or does it need to be coupled with Capella? No, it can be used standalone on both Couchbase Lite and Couchbase Server.
Awesome. Thanks.
Any other questions?
There's one more here, Wayne or Mark. It says, can you shed light on security as you're dealing with a large amount of data? I think that a large amount of data, including the edge. We do have some security information that I'm happy to send out afterwards, but and touch base with you, Yogi. Do you guys have anything else?
Yeah, of course. We have an awesome security story, right? We're used in, very critical business apps like that store healthcare data, financial data, even government agencies, and there's a lot of restrictions in many of the applications that we're used in, and we cover it from cloud to edge. So we have both storage, transport, and access control is all secured, right? So you have on device, you have AES 256 It's AES encryption. I forget the specs off the top of my head. I haven't had to say that in a while. But it's military grade encryption on device. Between device, we use device in the cloud, or between devices in peer-to-peer, we use TLS. And then when you're moving data out of the cloud, we enforce access control down to the individual user, right? So when you're syncing data, you're syncing the data that you have access control to. And our access control models provide read side control down to the document level, so the record in the database. And then we have write side control down to the field level. So you have really, really strict control over the access control and the encryption in motion and at rest. And one other thing we have is we have the ability to revoke access control, right? So if you have access control and a device has synced down data, and then you remove the access to the records for that user that was used for that synchronization, then the records will be purged from the devices that it's synced to. So you actually just unwind the access control. So these are things you really need to worry about and think about when you're dealing with business data and sensitive data and privacy data. And we have it built into the system. It's automated.
Yeah, agreed. And I also put a little link in the chat there too. And I'll add it to the docs section so that everybody has access to it. But link to our site that talks more about security. So we do take that very seriously. If there's no other questions, I want to thank everybody for tuning in today. Thanks especially to Mark and to Wayne. Love to see the sync demo. Very, very cool to see everything in action. So from coast to coast, I wish you all a wonderful day, and we'll see you at another webinar very soon. Take care.
Thanks, everyone. Bye.
Bye. Thanks.